Hello and welcome dear students. I am Shravan Kumar, your maths lecturer. We have started with the topic mathematical logic. So let us continue with the same topic. So today's topic, today's subtopic is rules of logic or algebra of logic. Algebra of logic. So here we will see 10 important rules that are used to simplify the exercise 9.1.9. So the first rule is, or the first law is idempotent law. Idempotent law. Idempotent law is, if suppose we have two statements P and P. First statement and second statement, both statements are same and they are connected by the connective and, then the resultant statement is also P. This is also valid for disjunction, that is for or also. Suppose we have two statements P, we have same statements P or P, then the resultant statement is also P. So the first rule, idempotent law, is what? When we have a statement which is connected by, we have a statement, same statement P and P or Q and Q or R and R, if they are connected by the connective and or, then the resultant statement is P also. For example, if suppose if I say P double implies Q, this is, let us say this is first statement, and again if I say P double implies Q, this is second statement. If we have both statements same and if they are connected by the same connected by the connective and or, then you have to write the statement, same statement P implies Q. So the first rule is what? P and P is also P and P or P is also P. Second statement is what? Second rule or second law, commutative law. Commutative law. As you know, commutative law means what? 2 plus 3 can also be written as 3 plus 2. This law is known as what? Commutative law. So in logic, P and Q can also be written as Q and P. P and Q can also be written as Q and P. Both these statements are equivalent. Or if we have P or Q, then this can also be written as Q or P. This can also be written as what? Q or P. This law is known as what? Commutative law. Third law is associative law. Associative law. Associative law means what? Association. Suppose we have three statements P and Q and R, then we can associate any two statements. That means we can write any two statements in a single bracket. Suppose we are writing Q and R in a single bracket, you can write P and Q also or P or R also. So this statement, if we have three statements, they are connected by the symbol and or. All three statements should be connected by and or. Then we can write any of the two statements in a bracket. Suppose here we are writing P or Q or R. This law is known as what? Associative law. Associative means what? Write together. Fourth, distributive law. Distributive law. Distributive law. What is distributive law? Suppose we have P and Q or R. One and one or. Distributive law is valid when we have one and one or. In associative law, all three statements are connected by either and or by or. Here we have one and one or, that is one conjunction and one disjunction. Then these statements we can write as P and Q or P and R. P and Q or P and R. Or second rule for, if we have P or Q and R, then this can also be written as, while distribute means what? Like multiply. So multiply by P or. So P or Q and P or R. This law is known as what? Distributive law. Next statement or next law is what? So these are the four law: idempotent law, commutative law, associative law, and distributive law. The fifth law is what? Involution law. Involution law. Involution law means what? Negation of negation gets cancelled. So if we have negation of P and if we write the negation of negation P, then the simply will write P. So negation gets cancelled. So similarly for negation of true, it is false, and negation of false, it is true. This law is known as what? Involution law. Sixth law is what? Complement law. Or let us write first De Morgan's law. De Morgan's law. So what is De Morgan's law? Like you have seen in sets and relations. If you write negation of P and Q, entire negation of P and Q, then this is negation of P and becomes here OR and negation of Q. So negation of all negation of P and Q can also be written as negation of P or negation of Q. Similarly for OR, P or Q, so negation of P or Q is what? Negation of P and negation of Q. Here AND becomes OR and OR becomes what? AND, while using De Morgan's law. So this is the sixth law. Next law is what? Seventh law, complement law. Complement law. So how to identify complement law? One statement and or negation of that statement. Complement law means what? Any statement and any statement or negation of that statement. So if you have a statement and or negation of that statement, then the law used is known as what? Complement law. So P and negation of P and negation of P. So we have the rule for and true is true. True and true is true. But because of negation here, the true becomes what? False. So the answer is what? False. For and, the answer is false. And for or, the basic rule for or is what? False or false is false. But here because of negation the false becomes true. So the answer is what? True. So complement law is what? P and negation P. For and the answer is false, and for or the answer is what? True. Last law, eighth law is identity law. Identity law. Identity law is what? If we have P and T, or so we have a statement P and second statement is always true, then the answer is what? P only. P and T is P. If you write the dual of this statement, then it becomes P or F. P or F is also P. So this is identity law. See, if you have P or F, P or F, the answer is for or F is what? P. So for and T we have the rule is what? P and T is P, and for P or F is also P. Third is what? If we have P or T, then what is the rule for or? If we both the statements are false, then the answer is not false, but the second statement is always true, therefore the answer is what? True only. Here next statement P, or write the dual of this statement P and false, the answer is what? False. So this is the identity law. And next law is what? Conditional law. What is conditional law or implication law? P implies Q, this statement is known as conditional statement. Then P implies Q can also be written as negation of P or Q. Using proof table you can prove P implies Q is equivalent to negation of P or Q. So without using conditional form, P implies Q can also be written as negation of P or Q. They are logically equivalent. Second is what? If we have P double implies Q. P double implies Q can also be written as P implies Q and Q implies P. P implies Q and Q implies P. So what is P implies Q means? Negation of P or Q, and here negation of Q or P. So this is conditional law. And the last law is what? Absorption law. Last law is what? Absorption law. So in absorption law we have P and P or Q like distributive, but both the statements should be same, one outside and one inside the bracket, and there should be one and one or. Next statement is what? P or P and Q. So the answer is what? P only. So this is absorption law. So with this we have completed 10 laws, that is idempotent law, commutative law, associative law, distributive law, involution law, De Morgan's law, complement law, identity law, and conditional law, and last one is what? Absorption law. So these are the important rules for simplifying exercise 1.9. Thank you.